going to start this session about eHealth. This session, some of the speakers will make the presentation in English, two others probably in Spanish, so there is simultaneous translation both languages. You can choose what language you want to hear. The first speaker is Dr. Knud Yderstræade. Sorry. He's from Denmark. His presentation is about innovative technologies in wound care, examples for a Danish innovation project, and a look into a crystal ball. So, when you want, please.
Thank you, Mr. Chairman. I hope you don't mind I do my presentation in English. My Spanish is not that well. So, anyway, a few days ago I listened to a talk from a Spanish colleague who really mentioned the virtual reality in technologies, showing a huge number of technologies to be potentially applied in clinical situations. Now, what I'm going to do today is to try and implement some of the clinical space that we have to use. And by doing that, I will take some examples from a Danish project that we are in the middle of right now, and we have some products developed and some products are in the crystal ball, so to say, but within 3 to 5 years, I believe we can apply them in the clinical situation. Oh, it doesn't work. Now, some of the aspects of what we're really interested in measuring in wound pathology, I've listed some of them, and I'm sure you have other ideas as well, and you feel free to comment on it. But at least also area and volume, also morphology and edema monitoring are some of the aspects that we really want to measure, talking about ulcers and wounds. Also, I believe that temperature registration is a good thing to do. I have a few things to mention around patient gait-derived problems in diabetic patients with neuropathy. And then I would like to focus a little bit on the patient empowerment, because we know that if we should use telemedical devices, we have to empower the patients to use them instead of coming into our clinics. And then, of course, there's the aspect of biofilm, pH, bacterial decomposites, and much more that we can address if we have got time to discuss it. Those are some of the things we have been encountered in Denmark, in our small country. We're trying to work on these technological solutions. I know there are some of you who are familiar with 3D scans, and some of you probably use it in the daily clinic. We have used about 3.5 years to develop this prototype. It's not encapsulated, it doesn't look that nice, I would say, but it's going to be. So that we can have 2 or 3 photos and have a 3D image of this also. As you can notice, there are 2 red spots here. If you have the one spot on top of the other, you have the most optimal situation to take the photo. So if you have 2 or 3 photos, you can get a picture like this. Sorry for the lights and so. But you can move around and you can see details in this also in a 4-foot amputated person. What is important for us as clinicians is the fact that you have to put a texture picture on top of this and not just have 3D scan. You can put a matrix down on your foot and you could do volume measurements as we're trying to evaluate in our clinical situation. But you have, as a clinician, the option to look at this also as something that really is naturally looking. You have the colors, you have the morphology. So that's the next step we should go further on. Instead of having a technical picture of a foot, we would like to have the morphology as well. Another project we've been working on is edema monitoring. We all know that edema is a serious problem for people with ulcers. It's a serious problem for people with heart insufficiency. And how could we sort of pave the way for individualized medical treatment of these patients? That's what we wanted to look at with this edema setup. Now, we used what we call a deep stretch sensor. As you can see here, it's a sensor built into a stretch material that can stretch to about double the length of normal. And in this, you change the capacitance and you can measure what happens in a wireless situation. So you can actually monitor the patient. It's not done yet, I would say, but in theory, you can monitor the patient in daily experience what happens if the person walks around. We all know that we're working with people with ischemic and venous leg ulcers in combinations, and how much pressure can be put on these patients. So we say if it's below 40 millimeter mercury in the distal pressure, we might have a problem by applying pressure. What I would like this to do is to qualify our opinion on this aspect and know what happens when people walk around at their homes. It might be that the pressure increases to maybe 80 or 100 millimeter mercury. So that would inform us of what really happens in the real world. Now, for you, those of you who wants to know, this is the equation, and I can tell you that you shouldn't give me any questions on that because I won't answer them. So it's very complicated, as you can see. This is a simple setup where you have a pump pumping fluid into this latex hollow foot, so to say, and we have these deep stretch sensors put on various positions. And we can measure what happens if you pull the fluid into it and see what happens to the stretch. The conclusion for these studies are that it's a repeatable setup. It could be suitable for trials in the early phase. We could monitor by use of a new sensor, and it's readily available. You can go in on this company's website and have it if you want to. But the problem, of course, is that it could be drifting with multiple tries. One thing we would like to have would, of course, to have put in an actuator in this system so that we can treat the edema. However, this material is not strong enough to create an actuator function. So it's just for sensing, so to say. The limitations, I just set them up here. It's, of course, a static situation, and we have to consider room temperature in this connection. There might be a reduction in foot pressure, and of course this system is a deformation of latex that cannot be used in the clinical situation, but it's a step on the way to give us an idea of how we can measure edema. One of the things I think we all keep in mind is the venous ulcers. How do we treat venous ulcers? Compression is the golden standard. Are there any other options that we can use in this connection? What we wanted to try and set out to try now is to use this fairly simple setup where you have a sort of a balloon down here that you put in behind the bandage, so you measure the sub-bandage pressure. It's a simple setup. You have this device that can receive information wireless, so you know what happens when the patient is walking around. What is the pressure? What is it created of a pressure if you walk around instead of sitting down? So we can have an individualized treatment for this patient. And say, if you do this, you have a huge increase in the pressure, and it will remove some of your fluid and improve your ulcer healing. So it's a very simple device, very simple setup, and I hope we can use it to sort of qualify the way we add compression to these patients. Temperature registration. I've had a number of good ideas on temperature registration down here. One of my big problems is, of course, that we have to take the ambient temperature into consideration, and how do we do that? We can measure temperature on the surfaces of a foot, for instance, no problem, but can we sort of compare it to real dive? Can we compare it to the ambient room temperature? Can we compare it to a foot that is ischemic, a foot that is not ischemic, and so on? I think there is a problem in this area. We wanted, in the first setup, to test it in patients with Charcot foot. As you all know, there's a problem with recurrency in Charcot foot, and if we have treated a patient with a Charcot foot, with or without an ulcer, we release them, and they come back maybe in some months or a year with an ulcer or a recurrency of their Charcot foot. We tell them, if we have treated them for some months, go home, have your offloading and your special orthopedic shoes, walk 5 minutes, 3 days, and let's see what happens. It's not really a good thing to do. I mean, we have to be more qualified in the way we guide people and sort of empower them. So I would like very much to have a temperature registration, for instance, put into a sock that registers temperature on a daily basis, on a continuous basis, and supply wireless data to the specialist at the hospital who can tell the patient you have to walk around a bit less than you did in the start, so we can see what happens and so on. We use this mode of visualization, and of course that's not a portable system. You cannot use that as a nurse in the home, but maybe the systems would come down. So we simply used infrared measurements of temperature to see how was the temperature dispersed throughout this foot. And in theory, you can imagine that this could be used in a situation where you want to guide the individual patient, but the apparatus, the system is too heavy and not for a nurse to carry around, I would say. Now, we all know that patients with neuropathy they have gait problems. They don't know exactly how they put their feet and how they sort of make their progression when they walk. So what we wanted to look at was to have a system that we could give real-time information for patients on how they really have their walking around. There could be a possible effect on also healing because we could enforce a sort of correct movement, and it could be useful in cases of individuals with neuropathy. So it's a very simple setup. You know all about these insoles that you can see how people have how they should be offloaded and so on. But if we combine these data to an app in a mobile phone and the patient can see how the pressure has been during the day, they might sort of addict to the possibility of having a more perfect gait. Also, you could envisage that information could be given to the person walking around that you're actually putting too much stretch on your right leg and so on, so they could sort of come into a more normal walking function. It's still in progress. We don't have the solution here. Now, what we've been working on is patient empowerment. I'm sure most of you are familiar with using photo documentation of ulcers in the patient's own home, and we've been using that for diabetic foot ulcers. But if we should empower the patient to take the photos themselves, we cannot make them dance around and try to take a photo on their foot. So what we did was we tried to combine two mobile phones with cameras, and this was just a simple setup. My PhD student Benjamin is putting his foot here. I don't think there was an ulcer, but anyway, we did some prophylaxis here. So you could place the camera here or hang it anywhere in the room if you have an ulcer on the back. And then this signal here would be transformed to another phone, cell phone, so you can actually guide the way you took the photo by this phone. Understand me? So you could position you so you have the best photo really by looking at this integrated iPhone in this case or Android. So the picture would be the best possible to send for your professional carer. Now in this process, we shouldn't forget about the relatives and the patient itself. It's very, very important. So we discussed about having a mood meter. And what is a mood meter? I'm sure you know what I mean. So Mr. Jensen could sit in his chair and he felt immobilized because of his ulcer. He was depressive, there was nothing to do, he couldn't walk down to the grocery and buy things and so on. He couldn't go to the kitchen and other things. So how was the mood that day for Mr. Jensen? And how was the mood the next day? These data could be accumulated and showed to the patient's relatives so that the relatives could say, we have a problem here, we should visit him some more, or we should talk to the professionals and say, he's going down the drain, really. Just a funny thing, but I think we could engage the relatives and the patient himself in that. So what is it we really want? And you're welcome to supply me here. I would suggest that we should work on a multi-sensor intelligent bandage, that we should incorporate a number of things in a sock, for instance, with temperature, maybe pH measurements and so on. So if we go that way, we could, if we can have it in a cost-effective way, have bandages that could tell us a number of things about this individual patient and move towards individualized medicine as we want in other cases as well. So it could be like temperature, it could be pH, it could be wound secretion, and it could be, and that's way ahead I would see, bacterial decomposites. Maybe some of you joined the biofilm session the other morning. We don't know much about biofilm, but maybe we can find some markers that we can have a fluorescent antibody made against, and we can visualize what kind of ulcer we're working with. I know it's far out in the future, but these are some of the things that we should use to try to qualify our evaluation of ulcers. Thank you for your attention.